Okay, our goal here is to understand what's going on here so we can find out the temperature of the bread when it cools. Hubble bubble wants to freeze fresh baked bread so she can preserve it. Puts a timer on. The time she put in the freezer, the bread had an internal temperature of 105 degrees, and the bread's internal temperature will decrease 15% each hour. Okay, well, the equation represents that. If we're decreasing by 15%, think of losing 15% on a test. Well, congratulations, you got an 85. That's a commendable score. It's also the multiplier that we want to have. So if we're starting at an initial value of 105 in terms of the degrees, then 0.85 is going to be the multiplier. That's going to show a decrease of 15% each month, or I'm sorry, each hour. Okay, now a guess and check to determine how long it will take for the bread's internal temperature to be less than 5 degrees. Well, guess and check is a pain in the neck until you remember you have a calculator. It has all these neat functions. Okay, in an interesting little, I don't know what that is. So we don't know. I mean, how long it'll take to get less than 5 degrees? Well, 85% of that's still going to be up around 80 something. And so it's going to require a number of hours. Let's try 5 hours and see where we're at. Well, that's down to 46 degrees. We're waiting until we get down to 5 degrees, so it's going to take more than 5. This calculator has a function where you go second enter and it'll bring back everything. Let's try 10. We're halfway there. Okay, still we're only at 20. So I know it's more than 10. So we keep going, maybe 15. Okay, we're getting there. We want 5. So 18. There's 5. But 5 degrees rounded to 2 decimal places. Well, I can get closer to 5 if I go up another, 19 or so. Whoa. Well, that was too much. I got below 5. So I go back 18.5. Okay, that's closer. 18.6. Ooh. 18.7. Okay, I'm really close to 5 degrees now. This is probably going to get me over it. There it is. But between here and here, I'm 2 100ths over. I'm about 5 100ths under. So if I do that, it's somewhere between 7 and 8 if I'm rounding to 2 decimal places. So if I go in the neighborhood of, I don't know, that was almost a little, that was too close, that was too far. So if I say 7.4, ooh, that's pretty darn good. 7.41, 7.42. I'm going beyond. I kind of like doing this stuff. 7.48. Whoa. How's that happening? Oh yeah, I want to get smaller. 7.4. Wait, decimal. Okay, 7.3. There it is. You know what? I'm going to call that pretty good. 18.73. 18.73. Now that's neat, and some of you might think that's fun. I kind of do, but some of you might not. There's a better way. We want to find out when this thing is equal to 5. Now we did some of this yesterday. 5 degrees. If we're trying to get to that, and that's ultimately the number that we got, 5 is what we want 105 to turn into. So if I say 105 times 0.85 to the x power, yesterday we kind of learned about how to get that out of there, but there's an order of operations we got to go through here. The first thing is you got to make sure you have a base to a power first. But if we divide by this 105, 5 divided by 105, that's a weird number. It's a decimal number. We can leave it as a fraction for now. So I've simplified this to be 5 over 105 and said that's equal to 0.85 to the x power. It is at this point that you want to do the change of base formula, to do whatever it is it takes to get this x out in front. If I take the log of both sides, I got the log of 5 over 105, keep that in parentheses, equals x times the log of 0.85. Okay? It's at this point here that you can kind of get that x that's out in front. If you divide both sides by the log of 0.85, and put that into your calculator as you see it, you're going to cancel this and you're essentially solving for x. Okay? It's the log of 5 divided by 105. Close your parentheses around that because that's the numerator. We're dividing that whole thing by, it's hard to see there, but the log of 0.85. And if I do that, there's my 18.73, and it goes on, 33333. Now, guess and check. Got us there as well. One might argue that guess and check is quicker. The more you do this, the better you'll get at it. The more we saw yesterday that we did this, the more you can take it from here and basically say it's the log of this divided by the log of that. You always divide by the log of the base. You'll get better at that. It just takes practice.